Have you ever stopped to think about how your phone call doesn't just smash into the thousands of other calls happening all around you at the exact same time? It really feels like it should be absolute chaos. Well, the answer is actually one of the cleverest tricks in all of modern technology, and we're going to break it all down. No, really, think about it for a second. If you and I are in the same room, we can't just talk right over each other and expect anyone to understand what's going on. So how in the world can millions of phones share the exact same slice of the airwaves all at once? It just seems like it should break the laws of physics. All right, so before we get to the really clever solution, you should know that the first answers to this problem were, well, a lot more straightforward. You could either slice up the frequency or you could slice up the time. And you can see the evolution of the idea right here. The first solution was something called FDMA. Just think of it like giving every single phone call its own private radio station. Simple enough, but you run out of stations really fast. Then we got TDMA. This is more like being in a super crowded room where everyone agrees to take turns talking, one after another, but like super fast. Also pretty logical. But then you get to CDMA, where the solution is for everyone to just talk at once. How is that even possible? The solution isn't some ridiculously complex piece of engineering. Nope. It's actually an incredibly elegant idea that honestly feels more like something out of a spy movie than a tech manual. It's all about creating a secret language.
And in fact, I can guarantee you've already experienced the real-world version of this yourself. The technology is just copying something we humans do completely naturally.
And there it is. That's the big aha moment. If you're in a busy room and someone is speaking English, but everyone else is speaking, say, French, Spanish, and Mandarin, your brain can just easily filter all that out and lock onto the one language you actually understand. All those other conversations, they just become background noise.
And that, right there, brilliantly explains the core of what CDMA is. Every single phone call gets its own unique digital code, its very own secret language. So even though all the signals are literally piled on top of each other, your phone knows the one specific code it's supposed to be listening for, and it can just pull that one conversation right out of the crowd.
So this code thing is the magic ingredient. But how does your phone actually, apply this secret language to your voice? Let's walk through how it works, step by step. It's kind of like a four-step dance. First, your voice gets turned into digital ones and zeros. Then, those bits get multiplied by that special, unique code. Now, this is the key moment. That process spreads your signal out across a really wide frequency, which makes it look like totally random static to anybody who doesn't have the code. But on the other end, the receiver uses the exact same code to reverse the whole process, collapsing the signal right back into your original voice. It's basically digital magic.
And using a method like this has some incredible benefits. For one, you can pack way more users into the same airwaves. It's also super secure. If you don't have the secret key, you literally can't decode the conversation. It's just noise. Which, by the way, is why the military was one of the first groups to get really excited about it.
Of course, no technology is perfect. Making all this work requires some very complex system design. All those secret language codes have to be designed so carefully that they don't interfere with each other at all, a property we call being orthogonal. Think of it like trying to create languages that have absolutely no similar-sounding words. And there's also something called the near-far problem. If someone is standing right next to the cell tower, their signal can be so strong it's like they're shouting, which can drown out somebody else's whisper from far away.
Okay, so this is a brilliant idea in theory, but where did we actually run into it in the real world? And why does this old-school tech detail still matter today?
Well, CDMA was the absolute backbone of the 3G revolution. If you remember that huge leap from just making calls on your phone to actually being able to browse the web and use those early apps, well, you have CDMA to thank for that. It was the key technology that finally unlocked enough capacity for the mobile internet to become a real thing.
So we know it was a big deal, but let's try to put a number on it. Just how many more people could you fit into the same slice of airwaves using this whole secret language method?
About 200, yeah. In an ideal system with a pretty standard 5 MHz bandwidth, CDMA could handle around 200 people at the same time. This was a massive, absolutely game-changing leap in efficiency compared to the older ways, and it's what made the whole mobile data boom possible.
So when you look at the whole history of mobile phones, you can really see CDMA as this crucial turning point. 2G, that gave us digital calls. But 3G, powered by CDMA, that gave us the mobile internet.
And even though we've moved on to 4G and 5G now, they use technologies that built on all the lessons we learned from CDMA about managing interference and capacity.
So let's wrap this up, shall we? The key thing to remember is this. CDMA's genius was letting everyone talk at once by just giving each person a unique code, their own secret language. And that simple, elegant idea unlocked the massive capacity we needed for the 3G mobile internet and made our signals way more secure by hiding them in plain sight. And you know, that leaves us with a really fascinating question for the future. We learned how to hide entire conversations in what just looks like static. So as we move forward, what other incredible things are we going to be able to do by creating new secret languages in the world of technology? What's the next impossible problem that we can solve by hiding the solution right in plain sight?